All right. So when I picture software development in an ideal world, I see ourselves. We are building like modern systems with cutting-edge technologies and elegant tools and clean workflows. But most days, modern software engineering feels like building IKEA furniture without any instructions. So you're handed this pile of parts, some with funny names like Terraform module, build config, or final pipeline.yaml, which of course is never final. And before you know it, you're trying to assemble this microservice, and you're not quite sure if the first step towards deployment is doing this ritual dance around the staging environment, or waiting for the stars to align correctly before you hit the deploy button. And eventually you get it running, kind of, but there's a couple of screws left over, but hey, the dashboard is green, so who cares, right? And this is what cognitive load does when it goes unmanaged. We as developers, we spend more time thinking about how we need to do our work than doing our actual work. But there's some good news as well, because we can actually use cognitive load to our advantage. It isn't just a problem we should eliminate. So in this talk, we're going to look what cognitive load really is, how it messes with our ability to think clearly, and what we can do to use it to fuel motivation and creativity. So let's imagine you're building this greenfield project. And at some point for this project, of course, you will need a database, because what great project ever was there that didn't use a database? Now you're in luck because the company you work for is using one of the 3 major cloud providers. So provisioning a cloud resource should be pretty simple, right? Well, there's a process to requesting cloud resources like databases, and that process is somewhere. You're not quite sure what it is, so you go full Sherlock Holmes mode, and you start asking around in Slack and to your colleagues about how you should request these cloud resources. And after a while, you have figured out that in order to request a database, you have to create a ticket in ServiceNow. I had a colleague that used to say that tickets are the place where innovation dies. And I kind of agree with that. But you don't really have a choice, so you shed a small tear, you man up, and you fill out this very confusing ServiceNow form. And then you wait for a bit, and you wait a bit more, and 1, 2, 3 days go by, and nothing seems to happen. Your ticket is still unprocessed, and you still don't have any databases. So you ask around a bit more, and it turns out in order to get your ticket approved, you first need to get past the Sacred Cloud Committee, which is a group of non-technical stakeholders that meet once a month to determine if your database is actually worthy of existence. Now, of course, the last meeting was 2 days ago, so now you have to wait a full month to get your database provisioned. And it's at this point that you start to wonder, like, do I even need a database? Can't I just use a workaround to avoid finding all these company processes? Is this something that feels familiar to any of you, that you take workarounds to avoid fighting company processes? Yeah, good. I see quite a lot of hands go up. Yeah, well, it's not good, but it's at least I'm happy that you recognize this problem. Another example. Let's say that every Jira ticket you open looks like this, It is way too detailed. It tells you what to do, where to do it, how to do it, right down to the file names and line numbers. Even the commit message is already specified for you. There's no decisions to make, no exploration required, no thinking required. And the worst thing is that you could even automate this, right? And you did, because you trained this AI model, and it can churn out 10 of these tickets in a couple of seconds. So you proudly show that AI model to your tech lead, and he just shakes his head in disbelief, and he says, no, but that is out of scope for this sprint. So there you are, still manually pasting copy and code into your IDE, and even your kid's first grade homework feels more stimulating than doing this kind of work. So we just saw 2 examples, one of very high cognitive load due to unnecessary processes or poor processes, and one with very low cognitive load due to micromanagement. And unfortunately, these two examples have not been made up, or at least not been made up entirely, because I've seen these things happening at different companies. My name is Bas, and I've spent quite some years working on the intersection between software engineering, platform engineering, and developer experience. And that basically means I've seen these problems from both sides, right? I've been the guy or the developer banging my head against a broken process, and I've been the person creating tickets to get a database proficient, and I've been the person trying to fix these issues at scale at different companies. So my work basically meant I spent quite some time thinking about how we as engineers can, spend more time on building cool and valuable stuff and less time on the nonsense. So as a consultant, I get to see a lot of companies from the inside, of course. And for the past couple of years, it's a bit of a trend that most of them seem to be struggling with cognitive overload in one way or another. So when I started my career about 10 years ago, everything used to be much simpler, right? You would write some code and then throw it over the fence to the operations team, and they would get it deployed for you. And of course, we figured out that's not really ideal, but at least it was very simple. But today, everything is very different, right? The whole shift left DevOps movement, it brought us so many good things, but it also made the load on engineers skyrocket. So you're now expected to be a backend engineer, infrastructure wizard, a DevOps guru, and security expert. And it would be pretty cool if you also know at least the 2 front-end frameworks that are popular this week. So companies are pretty overwhelmed by these issues nowadays. And frankly, many of them are kind of stuck in a cycle trying to fix this. And they're trying everything they can, but without much success. But today we'll talk about some strategies that will actually help you to tackle these problems. So this is the plan for today. First, we will try to understand what cognitive load actually is, because a problem well defined is a problem half solved. Then we're going to talk a bit about motivation theory and how that ties into cognitive load. And finally, we will see how to put these strategies into practice to actually change things for the better. But before we try to understand cognitive load, it's good to take a step back and think about how our minds actually process information. So let's say you are at work and you're reading this conference page, which is full of acronyms. Maybe there's some kind of spaghetti diagram that's supposed to be your application's architecture. Slack is going off. You're talking to your colleagues all day long. And all of these things, the words on the page, the acronyms, the Slack messages flying by, and the conversations you have with your colleagues, those things, they all hit your sensory memory first, which is basically like a super fast inbox. And unless you pay very conscious attention to the things that hit that inbox, they are forgotten really fast, within a couple of milliseconds, basically. Now, let's say you do manage to pay attention to one of the things hitting that inbox. Maybe you are reading a conference page about how your CI pipeline works, and you're really studying that, and you're making good progress into understanding it a bit better. If at some point during that process you get distracted by an incoming Slack message or a colleague that asks a question, then your working memory clears out pretty fast again, so you forget the thing you were working on. If you do manage to keep paying attention, eventually you start understanding the topic a bit better. Maybe you can relate back to how the CI pipeline used to work at your previous employer, for example. You start to make sense of things. And once that happens, things really get interesting, because at that moment, that knowledge starts flowing into your long-term memory. And that's where expertise lives. And your long-term memory stores information in structures we call schemas or mental models. And the more you work with these mental models, the more developed they become. And the more developed they become, the easier they are to be retrieved at a later stage. Now, another way to think about this is described in this book, Thinking, Fast and Slow. And it explains how our minds operate using 2 systems, System 1 and System 2. Now, System 1 is fast, intuitive, and emotional, and System 2 is slow, deliberate, and logical. So, System 1 is very closely tied to your working memory. And System 1 relies on that working memory to make snap judgments. For example, when you recognize a familiar face or a familiar voice or sensing danger, it's not something you really have control over, it just happens. And System 2 is much more tied to your working memory. Whenever you're making calculations in your head, trying to follow directions, trying to solve a complex problem, That's when you're really learning on that system 2 and really leaning on your working memory. Now, your working memory, or system 2, is very limited. I think this is one of the most highly cited papers in psychology, and it describes that you can only ever hold like 7 plus minus 2 things in your working memory at any given time. And later that number was revised down to as low as 4. So it was even worse than what the author of this paper thought in the beginning. And this is also the reason why context switching is so brutal, right? Because the expectation is that you are working in a productive manner, you get distracted by something, and then you pick up where you left off right away again. But because that working memory is so limited and it clears out at that point, by the time you pick back up after your distraction, you need some time to reach that same productivity level again. Now, the funny thing is we can even test the limits of our very limited working memory right here, right now. So we're going to do a quick experiment all together. In a minute, I'm going to show some numbers on the screen for a couple of seconds. And I will take those numbers away. And once they're gone, we're going to recite those numbers. And we're going to add 1 to each of them. So for example, if the screen shows the numbers 2 and 4, we're going to recite 3 and 5. So here goes. That should be enough. So altogether, 6, 3, 1, 3. Great. So you can already imagine that if this was only 4 numbers, but if this would have been 8 or something, it would be much, much harder. And I myself would probably fail as well, so I kept it down to 4, just to be safe. Now, the funny thing is, while we were doing this, we were heavily leaning on our working memory or on our system 2. And when we do that, there's also some physical responses taking place. So your heart rate increases just a tiny bit when we just did that. Your skin gets a little bit sweatier, and your pupils get a bit bigger as well. So just like with any good CPU, we kind of warm up a bit when we do calculations, which I think is quite funny. So now you might wonder, if our working memory is so limited, how do we accomplish anything useful, right? Because we do accomplish pretty awesome things. Well, it turns out our brains are pretty terrible at remembering random numbers. So 5202, it's just 4 random numbers. But if we reverse that number, we get 2025. And all of a sudden, those same 4 digits, they become so much easier to remember. Because this is a pattern we have stored in our long-term memory. This is a schema, because this is the year we're currently living in. And this is what we call chunking. So we chunk bits of information together to make it easier to comprehend. And this is what we do all the time in our daily lives, but also in software engineering, right? We chunk information, for example, in design patterns. So we don't have to remember like 30 lines of code. We just remember, factory pattern, builder pattern, that kind of stuff. We chunk mental models of architecture, event-driven architectures, service-oriented architectures, without having to remember all those tiny details. So by chunking, we can achieve pretty amazing results despite our limited working memory. Which finally brings us to cognitive load. Because cognitive load is the strain placed on our working memory when trying to understand, learn, or complete a task. So it's the total amount of mental effort being used by your working memory at any given time. So when you're solving a problem, or learning something new, or just trying to remember which microservice did what, you are spending some cognitive resources. Now, the psychologist John Sweller, he defined 3 different types of cognitive load. The first one being intrinsic, the mental effort required to understand the complexity of the material itself. So intrinsic load is the inherent difficulty of a task or material. For example, how do I consume Kafka messages with Kotlin and Spring? There's also extraneous load, the unnecessary mental effort caused by poor design or distracting information. This is the load added by complex processes or poorly presented information that complicates a task. You are also experiencing extraneous load right now because of my horrible English accent, which makes it harder to understand for you. Another good example of this is being blocked by poor documentation for internal documentation within your company. And finally, we have germane load. And this is the brain power you spend building new mental models, aka the schemas for your long-term memory. So this is the good stuff, basically. And a good example of this is, how does the service I'm currently working on fit into the big picture? To give a bit more concrete examples, I think trying to understand Kafka topics and consumer groups is a great example of intrinsic load. Because topics and consumer groups, they are core to using Kafka correctly. And they are essential for achieving things like scalability, fault tolerance, and ordering. So this kind of complexity is intrinsic to the nature of the task. You can't really hide it in any way. You know, if you are debugging or building Kafka-based systems, you have to understand these things to do your job effectively. Okay, before I continue, who here loves skilled agile framework? Nobody? Oh, good. Otherwise, you might want to close your ears for a bit. Because I think SAFe is a great example of extraneous cognitive load. You know, it looks great on a slide deck, but it's a cognitive nightmare, to be honest. You know, there's layers of roles, meetings, and ceremonies, like the inventor got paid by the acronym. And you as a software engineer, you have to navigate agile release trains, product increments, synchronization sessions, solution trains, and a whole glossary of abstract nonsense that has nothing to do with solving actual problems. It's a bit like being hired to cook and then spending all your day in meetings about how the kitchen layout should be. So SAFe often creates more coordination about the work than space to do the actual work. In other words, it takes a lot of effort, but there's very little benefit. And finally, an example of germane load is learning hexagonal architecture, because that helps create mental models that help you understand the structure of a system. So it helps you understand how responsibilities are separated. It helps you to determine how to add or modify functionality safely. And of course, you know, studying hexagonal architecture takes quite a lot of cognitive resources. But that effort makes it easier to reason about the system later. In other words, it's the kind of load that pays off in the long term. So now, as you've most likely noticed from these examples, each type of load doesn't just appear out of nowhere. You know, it's shaped by different forces, by different actors. So intrinsic load comes from the nature of the problem and the technical decisions you make around it. So if you choose a distributed architecture or work in a very complex domain, you're accepting a certain level of cognitive weight or intrinsic load. The extraneous load, on the other hand, is mostly man-made and not the good kind of man-made. You know, it's shaped by our company's processes, policies, and internal tooling. And it's very much a byproduct of how we run our organizations. And finally, there's germane load. So it's the mental effort we invest in building mental models. And if that happens or not, very much depends on how the organization supports its developers. So do developers get time to learn? Are they solving meaningful problems? Is there space for reflection, or is it just, you know, building features all the time as fast as possible? And understanding who influences what will become more important once we start talking about strategies to shift the balance in the right direction. But to make this a bit more concrete, let me tell you a short story. So there was a developer on my team. Let's call him Mark. And Mark is a very smart, curious guy. But to be honest, Mark was also a bit bored. You know, for the past couple of months, he only got to work on this legacy system to fix some bugs. And he was itching for something interesting, you know, a problem he could really chew on. And he was looking for a way to grow and to stretch his skills. And then Mark got assigned a new task. And that task is to build an internal to-do list app. It was supposed to be a simple CRUD app, you know, maybe a few user roles, but nothing fancy. So a couple of weeks go by, and then Mark demos his solution. And his solution was anything but simple. You know, it used blockchain for task immutability, microservice with event sourcing, of course, multi-cloud deployments because vendor lock-in. And Mark even created a custom UI framework because React felt too limiting for his to-do list app. And we had the same response as you had. We all kind of laughed, but we also kind of understood. Because it isn't that Mark hates simplicity. He did this because he was bored. And boredom for us developers is very dangerous. So when people talk about motivation, they often assume it's all about carrots and sticks, right? About punishments and rewards. But it's a very outdated idea. And in this book, Drive, Daniel Pink describes what truly drives us knowledge workers. And he breaks it down into 3 key elements, which are autonomy, mastery, and purpose. So for the autonomy part, developers want the freedom to make their own decisions, to choose the tools they want to use, to shape the solutions and own their own outcomes. And once you take that away from them, once you force them to tick boxes and follow process for the sake of following process, they will disengage pretty fast. But if you give them autonomy, they will do awesome things. Maybe sometimes a bit too awesome, like Mark did, but that's not rebellion, it's a signal. And the signal is, I want to be in control of my work. For mastery, we want to get better at things that matter. We want to learn, grow, and stretch our skills. But if the work is too easy or too repetitive or too much painting by the numbers, we start to look for our own challenges. And that's exactly what Mark did. There was no challenge, so he fabricated some challenge for himself. And finally, purpose. We want to do work that matters, something that contributes to the big picture. And when we don't see that, we lose motivation fast. But if you give us a meaningful problem and something that has impact, we will really lean in, even if it's hard, and maybe especially if it's hard. So one of the takeaways here is that whenever you encounter a complex solution or an over-engineered solution, the thing you see is often just the tip of the iceberg. The real problem hides beneath the surface. So whenever you encounter one of these things, like these over-engineered solutions, don't ask, why did you do this? But instead wonder, what need wasn't being met that led to this mess? Because the truth is, Mark doesn't want to build blockchain-powered CRUD apps. He wants work that meets his needs for autonomy, mastery, and purpose. So we talked about Mark. Now let's talk about Sarah. And Sarah, as opposed to Mark, who was very underwhelmed by his work, Sarah is a bit overwhelmed. So Sarah recently joined a new team that's building some critical backend services. And Sarah is a smart and curious woman, and someone you really want to have on your team. But after Sarah started on this new team, she quickly realized that the services this team had built was just a tangled mess, and nobody really understood the full context. The documentation is outdated, and getting answers is mostly just a game of Slack roulette. She needed like 10 tools just to get the app running locally. And half the tickets she works on, they get blocked by some external dependency. So every day for her felt like she was wading through the mud. And she loved coding, but she could never make any real impact due to all of this overhead. And at first, she tried to fix things in a very constructive manner. She raised issues during retrospectives. She started suggesting improvements. But nothing changed. And if nothing changes, frustration builds up slowly over time, like the pressure inside a volcano. And then one day during stand-up, Sarah just lost her mind completely. She had this big rant about everything that was wrong. And of course, all her teammates, they recognize these issues, so they're kind of nodding along. Yeah, indeed. But still, nothing changed. Well, actually, one thing did change, because after that moment, Sarah's fire was gone. The volcano had erupted, and she stopped asking questions. She stopped offering her ideas. And eventually, she quietly switched to another team, and a bit later even to another company, which of course is a huge waste of talent. And she didn't leave because the work was hard, but because her needs for autonomy, mastery, and purpose weren't being met because of this very high intrinsic and extraneous load. So it's good to realize that motivation never disappears in a single moment. It erodes slowly over time, with every unclear ticket, every broken process, and every day spent fighting the system instead of solving real problems. And the thing is, it usually doesn't disappear silently either. And I think one of the key takeaways here is that complaining is not a problem, as long as it's constructive at least. And I'm not just saying that because I'm Dutch, and I love to complain, or we love to complain. But people complain because they care, but they feel powerless and they can't improve things on their own. So take these complaints seriously. And always remember, it's not the complaining that's the problem, as long as it's constructive. But once people stop complaining, then you really should get worried. So there was quite a lot of theory. Now let's bring that into practice at this fictive company, Tangerine, which builds real-time fruit logistics software to track the freshness, location, and estimated shelf life of all kinds of fruit. And Tangerine is a pretty serious company. They're mid-sized, and they have all these awesome technologies, event-driven architecture, Kafka clusters, AI tooling, the whole shebang, basically. And there's a lot of very talented people working at Tangerine. But they're kind of stuck, you know. They've got a system that's grown wild. And they spend a lot of effort on managing all this unnecessary complexity that they've built up over the years. So the intrinsic load they have to deal with on a daily basis is through the roof. The extraneous load is sky high as well. You know, they have all this poor documentation, they need ServiceNow tickets to request databases, and there's all kinds of legacy policies that slow them down a lot, but are never questioned because, you know, we've always done it this way. And most importantly, germane load is at an all-time low. So there's no clear vision for management, no one feels like they're learning anything new, and people are just trying to survive. So they are working on tasks that don't really challenge them intellectually, and there's no space for creative problem solving and no room to grow. So one of the teams at the Tangerine Systems is Team Pulp Fiction, and they are responsible for the fruit freshness forecasting engine. And this is one of the teams that's really struggling. And now imagine this team takes a step back, takes a deep breath, and starts trying to shift things. And they realize very quickly that the first step towards lowering their intrinsic load is not to rewrite everything, preferably in Rust, but to start learning together. In other words, they have to start by fostering germane load, because without learning, they can't create the mental models for their long-term memory to make their systems simpler. So they start, you know, with the obvious things like knowledge-sharing sessions and paired programming, not just to share knowledge, but also to share context about the systems. But what they find is that these knowledge-sharing sessions or pair programming experiments, they often lead into heated debates. And that makes sense because, you know, there's so much cognitive overload happening at Tangerine, it quickly leads to frustration. So the team at Tangerine is a bit stuck, you know. Every stand-up turns into this mini debate. And the thing they're dealing with right now is that their CI pipeline is way too slow. So their pipeline takes 25 minutes. And half of the team thinks they should switch CI providers, and the other half of the team thinks, you know, they should just optimize what they already have. And they can't really reach consensus on what to do. But in the meantime, their pipeline still takes 25 minutes, which is a huge waste of productivity, of course. Until one day, one of the engineers reads this book, Think Like a Rocket Scientist. And this book is about how to approach problems with the mindset of a rocket scientist, using curiosity and experimentation to tackle these complex challenges. And one of the lessons from the book is to use hypotheses over opinions. Because when people form opinions, they often become attached to them, and they feel the need to defend their opinion. And by contrast, an hypothesis is an idea or theory that is subject to testing and change. So it's not about being right, it's about exploring a problem. So the next time the CI discussion arises, this person says, you know, let's test an hypothesis. If we parallelize the test jobs and clean up some unused steps, we can shave off 30% of the build time. We will try it on a feature branch and just see what happens. And then from that point onward, suddenly the conversation shifted. Because it wasn't about who was right anymore, it was about trying a small thing and seeing what happens and learning from that thing. So in the end, they tried that. They shaved like 9 minutes off their pipeline, which is not perfect, but it's a real tangible improvement. And because this was framed as an hypothesis, no one had to defend their ego. They just said, oh, that's nice. What's the next thing we're going to test? And from that point forward, all the discussions felt much lighter, and the team had a language for moving forward. And it is to test, learn, and adapt. So at Tangerine Systems, there's no shortage of autonomy. Every team can pick their own tools, their own tech stack, their own cloud provider. And on paper, that seems awesome, right? But in reality, things didn't go so well. Because multiple teams were building solutions for the same problems in very different ways. So one team would standardize on Kafka, and one team would standardize on gRPC, for example. And one day, during a messy post-incident review, someone finally said, we're not autonomous, we're just unsynchronized. So they started making a shift. And instead of giving teams freedom, instead of giving teams all the freedom, they started to talk about direction and purpose and some shared standards. And the result is that the team still has freedom, but now it's much more aligned. And so they started promoting this culture of aligned autonomy. And ideally, your leadership promotes such a culture. But the good thing is you can even start doing this in your own team without the buy-in from leadership. You can be transparent about your goals and trade-offs. You can have a clear vision within your team, even if your company doesn't have one, or you think your company doesn't have one. You can make the why behind decisions more visible. And if you're in a lead role, ask for outcomes instead of tasks. Resist the urge to tell people exactly what to do. Share the problem and not the solution, even if you think you have the solution. And the more teams get used to this rhythm of alignment on goals and autonomy on execution, the more space there is to create meaningful problem solving. And that's where germane load lives. So this is what they did to foster germane load. And after fostering germane load, the team is already doing much better. They started learning together. They've replaced loud opinions with testable hypotheses. And they're moving with aligned autonomy. And each team still has ownership, but they're no longer reinventing the wheel every time. And then something shifted. They started asking better questions. The motivation is back a little bit, but they are still tired, which you can see because 2 people have their eyes closed. And they're tired because even they feel more connected to their work now, it's still way too hard. The solutions are still unnecessarily complex. And that's the intrinsic load weighing them down. And of course, the goal isn't to eliminate intrinsic load, because it's the price we pay for real problem solving, but we can manage it better than what Tangerine is doing now. So one of the team members, Leo, he was building a simple feature. And that simple feature turned out to feel like doing a PhD thesis, basically, because every piece of the system just seemed so unnecessarily complex. And at one point, Leo just snapped. During stand-up, he said, we're solving a game of tic-tac-toe with quantum mechanics. And he kind of had a point. And this is a key moment again, because this is Leo's volcano erupting, just like we saw with Sarah before. Only this time, the team decided to take a pause and take a hard look at their architecture. So they're taking Leo's complaints seriously. And they started asking new questions. What is the simplest solution that still respects the problem? Because, not everything needs to scale into the millions. Not everything needs to be asynchronous. And by doing so, they began right-sizing their complexity. And maybe just as important, they made the decision to make decisions visible. So they started writing architecture decision records, not as a formality, but to create a shared mental model of their systems. So now when someone asks, why did we build it this way? It was written down, considered and discussed. And they even started writing design documents for bigger changes. Not long essays, but just to structure their thinking. And sometimes doing this even led them to walk away from a certain solution before even building it. And by doing so, little by little, their code base became less of a jungle and more of a map. Still complex, but the complexity was justified. So it's complex where it needs to be, and simple where it can be. And that's how they started managing their intrinsic load. And this also made them realize something that's also important, is that familiarity is not the same as simplicity, because they had spent so much time in the trenches that everything started to feel like it should be complicated. So when they were faced with an issue, their default was to reach for a complex solution, even if that wasn't the best solution. So just because they were familiar with complexity doesn't always mean it was the right approach. So the team made great progress into managing their intrinsic load by right-sizing complexity, but they still feel like they were juggling too many things. It's not just the code, but also the coordination between the teams. And that's much harder for the team itself to fix. And luckily, that's when leadership decided to step in, and they decided to start adopting team topologies. And at first, that seemed like just another framework, but as they dug a bit deeper, it became clear this was about structuring teams in a way that breaks down silos. So, for example, while Team Pulp Fiction could focus on building a notification system end-to-end, they no longer had to worry about setting up their monitoring stack, because that was now the platform team's job, of course. And the platform team that built an observability platform with integrated logging, metrics, traces. And the platform team also provides like a very clear golden path towards using this observability platform. So Tangerine made good progress, they are more aligned, more focused, more engaged, but the extraneous load is still a major hurdle. And the turning point came when one of the engineers finally decided to speak up. She wasn't like the loudest of voices, but she had quietly been tracking something for months. And that was the amount of time lost due to friction in the development process or to internal tooling or to poor processes. And she pulled together like a simple presentation for leadership. And there was no rants, no complaints, just simple facts. And the thing is that she showed is like, she showed on average how much time was lost for each developer each week. And multiplied by the amount of developers at Tangerine, that wasn't just an annoying problem, it was a crazy expensive problem. And this clear framing as a business problem unlocked the investment for a developer experience team. And that's when things really started to change, when it comes to the extraneous load. So, for those of you that are not familiar with developer experience, it's the experience developers have throughout the entire software development lifecycle. And it's often believed that DevX is mostly focused on tooling, like your programming languages, the tech stack you use, IDEs, that kind of stuff. And that's certainly an important part of DevX, but it's also about social factors and collaboration, and company processes, and that kind of stuff. So it isn't about making life easier for developers. It's about removing all the obstacles that prevent teams from doing their best work. So imagine every time a carpenter wanted to build something, he had to spend like half the day searching for his tools, and then fixing his workbench, and then get approval from his boss to use his hammer. Such a carpenter, he wouldn't be very happy, he wouldn't be very productive, and he wouldn't build the best solutions possible. And that's what a poor developer experience does to developers as well. So the DevX team at Tangerine came in not to build product features, but to clear the path for those who did. And of course, they didn't do this in isolation. They really started listening to the development teams and started trying to determine where the biggest friction points are. And one of the first things the DevX team at Tangerine did was to admit what any good engineer already knows. You can't improve what you don't measure. So they rolled out this developer experience measurement platform and started holding regular surveys across all the teams to get like a real honest pulse on where developers are struggling. And they started using this data to prioritize changes that make a real difference. And just like that, DevX wasn't just this abstract idea anymore, of which we all agree that should be improved. But now it was a shared trackable signal and something the whole company started to care about. And the response rate of these surveys, it was through the roof. It was 95% standard. And that happens because the developers really felt heard, you know. They know that the things they talk about in these surveys, they will get fixed by the DevX team. And all the friction that used to feel like just part of the job, it wasn't invisible anymore, you know. And now it had a team that actually was focusing on it. So this was extraneous load, and it's finally being taken seriously. And bit by bit, you know, the clutter started to clear. Developers didn't waste energy on things that should be simple anymore. So with the elimination of extraneous load, the teams at Tangerine finally achieved a healthy balance. You know, we started by fostering germane load, the effort we need to understand, the effort we spend to understand the problem, or learn new concepts, or improve mental models. And we need to do that before we can tackle the intrinsic load part. So they did it by starting using hypotheses over opinions and fostering a culture of aligned autonomy. Next up, they started using mental models to manage their intrinsic load, you know, the cost of doing meaningful work. And the key here is to keep your intrinsic load as high as possible, but no higher. You know, justified complexity. And they did this by right-sizing their complexity, documenting their mental models, and even adopting something like team topologies. And finally, they tried to eliminate their extraneous load, because that's the noise that doesn't help you solve any problems. You know, it just gets in the way. And we should eliminate it wherever we can. Of course, there will always be a little bit, for example, due to audit reasons or compliance reasons, but the less the better. And the developer experience team at Tangerine is still constantly hunting to fix friction points in the development process. So in the end, it's not about lowering load all the way around, because you need some load to stay motivated. But it's about redistributing that load and achieving a healthy balance. So Team Pulp Fiction is doing pretty good now, you know. The developers have room to think again. They spend their energy solving real problems instead of fighting with processes. And they still face hard challenges, but there is room for experimentation, and the weight they carry is the right kind of weight. So they have found their flow by balancing cognitive load. Thank you.